Hi, my name is Javier. I'm a research scientist at Flower Labs, and this is the first video in the second part of this video tutorial series that we have put together to show you step by step how to design a federated learning pipeline using Flower for simulation. In the first part, we presented you with every single component you need to run federated learning workloads with Flower. The dataset, the clients, how to partition the dataset and assign different partitions to every client, how to choose an aggregation strategy, and how to launch a simulation. What we're going to be doing now is to take that exact code base that you can find linked in the video description and enhance it by making use of the Hydra configuration system in a more clever way. Before doing that, which will be the content of the next video, I'm going to walk you through the basics of the Hydra configuration system. So let's take a look into that, and later on we'll take what we learn and apply it to our federated learning experiments.
Alright, so this is where we left it last time. If you remember, we had a main, split it into 5 or 6 big blocks. First, we got the dataset, we downloaded and partitioned the dataset. We created a function that will be called by the strategy to instantiate these virtual clients, which is the key thing in simulation with Flower. Then we define our strategy. We decided to go for the most standard strategy out there, Fedaverage. And then we were able to launch the simulation. We spent some minutes also talking about the client resources, because the virtual client engine in Flower allows you to spawn clients in a resource-aware fashion. So because the model we are using in this experiment was very small, we were able to run it fairly efficiently with just 2 CPU cores, which is what we set here. But we also saw how you can run these clients on the GPU and what are the implications of setting this value higher or lower. And at the end, we were briefly talking about the fact that Hydra under the hood creates a output directory for every experiment, and you can use that to save all your experiment results. Like for instance, the history, which is returned by every time you run the experiment. But in this first part of the video, we're not going to be talking about federated learning necessarily. Instead, we're going to be looking into the basics of Hydra. So later, we can come back to this main file and make some modifications to make it much more versatile. In the previous video, we were already using Hydra, but if you remember, we use a very standard YAML config, which it doesn't take advantage of probably almost none of the cool features about Hydra. So what we're going to do now is we're going to create a new file that I have already created, which is called toy. And I call it like this because here we are going to just use it as a demo to showcase different features of Hydra. So as you can see, this file does nothing. It just takes a config and it will print it. And in this case, it's taking the base config that is in the conf directory. And if you recall, this is exactly with the same thing here. It's exactly the config we wrote for the previous video. But now what we're going to do is we're going to do something different. We're going to create a new config that I'm going to call toy. And this config it's going to be in the conf directory as well. And we're going to use this to gradually add and go through different features of Hydra that are going to be particularly interesting for later upgrade our main where we use Flower. So we know already that if we want to have a variable in our config file, just like in a standard YAML, you would do something like this. Not food, not full, like a variable like that. You can of course create a hierarchy of these variables. So for example, you would do it like this, and you can set pretty much any kind of standard Python variable type. Like for example, here I'm gonna set a list. And then you can of course go even deeper and set something else, like blah, this could be a string. You are not you are not restricted on what's the type of these variables. And maybe more important, we can set another one called blah blah, which is going to be a reference to an existing variable in my config, for example, foo. So what this is telling me is that every time I want to use this variable here, it's always going to be using the value that is assigned to foo. And if I was to override the value of foo when I run the experiment, that will be also reflected in this variable called blah blah. So now that we have defined this, probably this is very easy, but let's start with the easy part. How do we access these variables? So for example, I'm going to print, if I do print foo, that will be printing the variable foo, which will be 1, 2, 3. If, for instance, I want to print my config, I want to print, let's say, bar bath will be printing this list. And we're going to do another thing, which is called, we're going to print my config.bar.more. And let's run it and see what happens. So first of all, here we have our config. I hope this is visible. Let me see if I can make this a bit larger. Maybe no. Let's do it like this. I'm gonna just make the code a bit smaller here, so it doesn't look ridiculous. Right. Okay, let's keep it like this. So as I run the code, first thing we're printing the entire config, following a YAML keeping the YAML structure, which is quite convenient to inspect the whole thing. And then we decide to print foo. Foo is 1, 2, 3, so it's printing the 1, 2, 3. Then we were printing bar path, which bar path is a list. It indeed printed the list. And then I wanted to print the node more. And note how I was able to print it, and I could see, okay, it has the element blah with value hello, and then the element blah blah with value, which is still shown as a reference. But the moment this variable blah blah is being accessed or used throughout your code, it will be, how can I say, it will be using the real value where the reference points to. For example, if I print cfg bar more blah blah, that will print 1, 2, 3. Why 1, 2, 3? Because blah blah is pointing to variable foo. What if, for example, now I say, oh, I want to change the value of variable foo? I would do it like this. Let's foo equals to 2023. As you can see, I run the code again. When printed the variable foo directly, I see 2023. When I print the reference as the last print statement, I see 2023 as well. So this is probably the most basic way of working with Hydra, which was pretty much the extent of the Hydra features that we used in the previous video. But we want to do something more exciting than this. All right. So what we're going to do now is to see how we can reference functions. So for that, I'm going to create a standard function here. I'm going to call it function test, and it's going to have 2 input arguments, let's say x and y. And what this function is going to do is going to do result equal x plus y. We're going to print the result. And that's it. So let's say that I want to define an element in my config. Let's call it my func, which And let's also return the result, which I want it to be, its value I want it to be obtained by executing a particular function. So how do we do it? So we need to use the reserved element or keyword called target. And this should point to the particular function I want to execute. In this case will be toy, because it's in the toy file, dot, and the name of the function test, followed by the arguments that this function needs. And this has to be keyed. You have to use key arguments. So the argument x, let's say, will be 1, 2, 3. The argument y will be 3, 2, 1. So, and if I run my code, let's remove that. Well, nothing different is being printed here because we are not doing anything with that function yet. But you can see, well, that my function config node is there. So how do we execute this? How do we actually call that function? So for that, we need to make use of a utility function from Hydra, which is called call. So from Hydra utils import call. Let's keep this less easy, but still you will see it's fairly okay. And then we're gonna call the output equals call cfg, and then what is the part of the config I want to run is called my func. So, and let's print this. So you can see we executed the function. So this was being executed, and it took us here. We did x plus y, which is this plus this, which is the result is 444. We reached this print statement. It was printed. It was returned, and then after returning, we print it again just to make sure everything is working as you would expect when running a function that adds two numbers and returns the result. So that's cool. Of course, for example, imagine that at runtime one of your arguments changes and you no longer want to use one of this particular value of y. You can overwrite it. My func, and then for example you will say, oh, y I don't want it to be 3 to 1, instead I want it to be 100. If I let's see, if now I run this code, let me just put some things so it's easier to start seeing the different sections of the code. If now I run the code, you will see that, oh, the first time I ran it was 444. We knew that. The second time it was, what we did is x plus y, but now y has the value 100. So the result is 223, which we can see here. So that's quite neat. But there are other situations where maybe your function, maybe some arguments are not available to be executed immediately, but much later in your code. So let's call this. So what you can do is, what Hydra can do for you is instead of calling the function, what it will be doing is creating a partial for this function. And you can think of this partial as a function, something that you can execute, but that requires some extra arguments to be fully executed without triggering an error because one argument is missing, for example. So in order to do that, we're going to still point to the same function. I'm just calling it differently so we don't overwrite this. But what we're gonna do is to set this to be a partial. And let's see what happens. I'm gonna call this no. So this, what will allow me is fn will be a function, it will be a Python partial that I can execute as a regular function, but I need to specify the missing arguments. For example, I would do something like this. What is the missing argument? According to this definition, the missing argument is y. So I'm going to pass it to, let's say, 1000. And let's call this. Let's execute this. And you can see, oh, we hit the partial part. fn hasn't been executed. It's only executed here when I fully define all the arguments. Let's see what will happen if I don't set this to partial, which by default this is not defined. By default, partial is set to false. So let's leave it. Yeah, we can leave it like this. This will trigger an error. Why? Because we are trying to call this function that we know it requires the input argument y, but we are not specifying it at any point. So let's make sure we use partial, and then everything's good. And why is this relevant? As I mentioned at the beginning, maybe you need to prepare a function at the beginning of your code, and later you pass it, for example, to a different object that has the missing variable to be able to call this function. So those settings is where this is particularly relevant. We'll see some example later in the second part of the video. And finally, okay, we know how to work with variables, standard variables, how to reference them. How about objects? We can work with objects as well. So for that, what I'm going to be doing is I'm going to define a simple class, which we are going to call my class. And let's define the init statement. And it's going to receive a x, and let's just keep x. Sorry. And what we're going to do is define a method for this class called printx squared. And this is going to do what it says. So it's going to print x by squaring it. Oops. So how do we, let's say we want to create this object, an object from this class directly from the config. So in order to do that, we do something as follows. We can set a node called myObject, and you will notice it has a very similar signature as what we use for the functions. But in this case, instead of pointing it to a function, we'll point it to a class, to my class. Because this is my class, so I'll point it to my class. And similarly to with functions, we need to specify all the input arguments that are needed. For example, x, let me set it to, let's put a 32. And now let's see, I want to print objects. Let's say I want an object equals. So we're going to be using another utility function from Hydra, which is called Instantiate. And what we're going to do is instantiate my object, which remember config.myObject just points here. and we need to import this. Let's call an instantiating. Yes. So that's gonna create our object, and then what we would like to do is to take the object and call this print x squared dot object dot print x, like that. Maybe something interesting you might have noticed is that I have the object, but I didn't get any sort of autocompletion suggesting me to that this is actually a method from this class. And the reason why the autocompletion didn't kick in is because the class this object belongs to is only defined at runtime. So this is something that VS Code, for example, in this case, had no idea about. And this is one of the, let's say, small prices to pay when using Hydra or probably any other highly configurable config system. Your code looks your code is more versatile, but this versatility comes at the cost of some small readability or some small usability overheads. Of course, you could have prevent this from happening if you were saying that object is of type, in this case, my class, and if we had done that, you would say, okay, object dot. You see now it's being suggested to use that method. So this might be fine if you are certain that all the objects you might be setting this variable to, for example, inherit from the same parent object that shares a lot of functionality, if not all. But this might not be realistic in all settings. Okay, so I'm gonna remove that for now. So yeah, let's call that. Let's execute this code. And as you can see, we got it here, objects, and then we instantiated our object, and then we call this method of the object, which is taking the value x and doing a power of 2. In this case, 32 times 32 is 1024, so which is what we saw here. So yeah, this is how you work with functions, how you can override arguments to your functions, how you can work with partials, so you can pass the missing argument later on in the code once that missing argument has been defined. And we have seen just now also how to work with objects. What we're going to see now is to work with objects as well, but with more complicated settings than just creating a very simple object in this case. So let me just put another of these so we can more easily read the terminal output. Okay, so what we're going to be doing now is to see what happens when, for example, I have an object and inside the object I have another object. So how does this object with objects get instantiated? And can I have any control on how this instantiation process looks like? So for example, let's say that let's define a new object that I'm going to call my complex object, just like that. And this is going to be a new class that we are going to call my complex class. And what we're going to do is that it's going to have only one variable, which is going to be, I'm going to call it my object, and it's going to be of type toy my class. By the way, this keyword here I'm using, my object, has nothing to do with the name here. It's just a coincidence that I'm using it like that. And as we know, this my class object will need a value for x. So in this case, let's make it a bit more interesting. I'm going to set x to be a reference to foo. Yeah, let's set it to foo. Well, let's add something new here. Set it buff, and let's set it to, let's say, I don't know, 24. How do I reference that one? Well, it will be something like bar buff. All right, so we have defined an object of type myComplex class that we need to create, which has one class element, one variable in your class called myObject of type myClass. So let's create this class first. I'm going to create a standard Python class. And we're going to, what we need to do is, this is going to be expecting an input argument named myObject, which is going to be type myClass. You don't need to specify the type here, but yeah. If you want to make it fully more versatile, you wouldn't specify the type, I think. And now this is going to be, let's say, self object equals my object. Something like this. So let's now run this. Complex object equals instantiate cfg my complex object. And we know that what complex object does, no, what complex object has is a class member called obj, which we know is a my class object. So we are gonna execute this method just for validation purposes. So if I run this, well, we just see this is the last line we were printing. So this is what happened. We instantiated a complex object, which had an object of type myClass inside, and the value of that myClass, the x value of that object, that child object, was set to 24. And if we do 24 times 24, that will get us 576, which is what was printed here. So that's pretty cool. But what will happen if, for instance, I have this parent object and the child object cannot be instantiated at the same time? Because what has happened here is that when I call instantiate, Hydra instantiated not only my class object, my top level my class object, but also this my object of type my class. In some settings, we might want to delay when instantiation of this object happens. Again, because maybe some of the variables needed to parameterize this instantiation are not available immediately, but they will be later. So how do we control this? So the way to control it is by making use of a new tag that is called recursive, which by default, if you don't specify it, is set to true. So we're going to set it to false this time. And what is it going to happen? What's going to happen here is that this object is not going to be instantiated. It will require us to call instantiate at some point later. So let's do it even better. No, let's do it like this. So for example, if now I run the code, this will trigger an error because this object is not instantiated yet. Yeah, it is still it hasn't been instantiated at this point. So to be certain that it hasn't, we can, for example, just print it. And what we're going to be seeing is like a config. So for example, here you see I have print the object inside my complex object class, and it's telling me that that object is of type toy, my class, and it has a value x equals to 24, but it hasn't been instantiated. If I want to instantiate it, you do something later. What we can do, for example, is to write a new method that is going to be called instantiate object. Instant object. Remember that because we have set this to false, this is still, the type of this is a ticked config, which is exactly the same type as all these elements we are passing here. So we need to create the object, instantiate the object from it by calling the instantiate method from Hydra utils. So let's do that. So what I'm going to do is I'm going to do a complex object instantiate. And now if I print this statement that I wasn't able to print earlier because the object was not ready, basically. Let me double check. Yep. Now we will be able to print it. So just to summarize, here I have instantiated an object that has another object as a child. But this second object, I don't want it to be instantiated at the same time. I'm going to delay that instantiation for later. Here, that later means in this line. So here I would imagine here I'm done a bunch of things, and I say, okay, now I'm ready to instantiate this object because whatever, I want to change some values. Now I'm ready to, now I have the parameters needed to instantiate it, for instance. So I can instantiate it, and now I will be able to treat it as a normal object. So let's execute this. All right, it's called instantiate object. See, I was here, I still print the config of this uninitialized object, then I call instantiate, and then I was able to indeed call this and see that the value of x squared is 576, which is the same value we saw earlier when we were not setting recursive to false. All right, so this is pretty much everything I wanted to show you regarding using standard features, standard parameters inside a YAML, the hierarchy, references, calling functions, creating a partial from a function, creating objects, creating more complicated objects, and controlling when this instantiation happens. So basically preventing it from being recursive. What I'm going to show you now is something a little bit different, which is relevant for FL experiments, I think, and in general for all experiments, which is using the keyword here, defaults. And what we're going to do is, let's say that we have a model, a machine learning model that we want to instantiate, and we want this, let's call this is going to be toy model, and we're going to make it ResNet 18. And let's say that we want to, how do we work with defaults? Because it's not so intuitive at the beginning, I think. So the way default works is as follows. In the defaults, there will be a variable called, this effectively will make, once the config is parsed, this will behave like this. It will behave like the toy model node will have some content here. But this will only be visible in this way once the config is parsed. So once the config is parsed, we will do something like print cfg toy model, and we will be seeing something. But why I want to explain this in a bit more detail is because now we are specifying ResNet 18, and what does this mean? So what this means is that in my config file structure, so here inside conf, when this YAML is being processed, I'm telling Hydra to go check into a directory called toy model. So we need to create it. And inside that directory, go and check the resnet18.yaml. So I'm gonna create that file. Toy model res. So this is something I found quite peculiar when I started with Hydra, but this is how it works basically. You are saying that your variable in your config, your variable toy model is going to be the contents of this resnet18.yaml that lives in a directory called toy model inside a file name called resnet18.yaml. So here what we're going to do is we're going to see how you can use this same methodology as we did for creating our custom object, and we are going to create, you can call any object. For example, I'm going to call a ResNet 18 model from PyTorch. So what we need to do, because we have already, this is the top level, how can I say, variable in our YAML, so this toy model would be the equivalent to this. What we need to do here is to start adding directly the target. And for this, what I'm going to do is to create a model from Torch Vision. So it's going to be Torch Vision models, ResNet 18, I believe it's like this. And then we're going to pass new classes. By default, it will be 1000, but let's do something more fun. Let's set the num classes to foo, for instance. So when I call this is going to be my object. When I instantiate this, I'm going to be instantiating a model from Torch Vision. And as long as Torch Vision, which is a package from PyTorch, is installed in your environment, your Python environment, it will be found without a problem. So, okay, I'm going to print that there, and I'm going to do something else. Model, let's say no, my model equals instantiate. I'm going to print one of these as well here. So let's see if I didn't make any typo, and we'll see. You see? So this is the last line. I'm printing the toy model node, which the contents of toy model is this. You can think of it as if it was looking like this. This will be the equivalent. And now what I'm going to explain is why we do it like this instead of in this other way. And you can see we can instantiate it as a normal object, which is my model, and then I printed the model. As you can see, this is the structure which in PyTorch look like this. This is a standard ResNet 18 with these 1, 2, 3 classes. And why 1, 2, 3? Because we set a num classes variable, which I know is one input argument of ResNet 18, is set to foo. But now let's do something a bit more interesting and see, okay, what if I have another model? What if I want to have, for example, a MobileNet V2? I think this is in text. So how do I change this? So you would just need to do, because by default, remember, by default I'm saying, oh, look into the ResNet18.yaml. Let's say I want to change it. You would do type model equals mobile. That's MobileNet v2. Okay, I think probably I've done some syntax mistakes, so let's see, import, no, torch vision models, import, oh, all right, so it's MobileNet v2, so like that should work. So there you go. We were able to, you see, we saw the target, now it's correct, I fixed the bug, and now I have instantiated a MobileNet v2 model. Just like that, you can very easily change from, oh, I want the default to point to this file or this file. So this is this is why getting used to work with defaults is good, because it allows you to toggle big parts of your config from one file to another. So this is everything I wanted to show you regarding the basics of Hydra. Just to summarize, we have seen how to use basic config properties, how to do reference, how to construct a hierarchy, how to define a function and call it using the call utility method, call utility function, how to define the function as a partial if the missing argument is going to be only available later, how to work with objects and instantiate them with the instantiate function, how to work with more complex objects that might have other objects inside, and how to delay when the instantiation of the child objects happens by specifying the recursive property and set it to false, for instance, and how to work with defaults, which is a very convenient way of very rapidly change from one config file to parameterize your main config file, which in this case is toy, with other smaller config files, specifically taking care of some components, in this case the model. So in the next part of the video, what we're going to see is how to take some of these lessons learned and apply it to our code base that we wrote in the previous video. We are going to see how we can change that, for instance, the strategy. So let's check that in the next video.